All right. So I'm Trey. I'm a web consultant. Workflow optimization is one of my passions, and along with that comes automated testing and code coverage. So first, let's define code coverage. Code coverage describes the degree to which your automated test actually tests your source code. That's kind of the summary. What does that mean for our tools? So from the perspective of a code coverage tool, code coverage means run the code and record which parts of the code were actually used. Okay, so some popular code coverage metrics are statement coverage or line coverage, which are almost the same thing. Statement coverage tells you which code statements were executed. Line coverage tells you which lines of code were reached within your program. Function coverage, which isn't looked at very often from my experience, but it basically tells you which functions were called, which can sometimes be different from the statement line coverage. And branch coverage is an interesting one. It tells you which branches of your code were actually entered. I'm going to go over what branches are in just a little bit here. So, any guesses as to what the statement coverage for this example might look like? Which statements aren't executed? Right, so console.log after that return is never going to be reached. I forced it in there this way, but it's sometimes possible for you to run your program and have certain statements not be reached. You know, maybe you have an if or an else. So the actual code coverage here shows that one of our 4 statements was unexecuted. And in fact, in this case, could never be executed, so that's probably a bug in our code. So function coverage. This is the simplest example for function coverage. We define a function, has nothing in it, and then we never call it. So our function coverage here shows that we have one function that was never executed. Now note that our statement coverage here is perfect. Every statement of our code was executed, but we're missing coverage for that one function there, which in this case I kind of cheated because it's a function that does nothing, but you get the point that these aren't exactly the same metric. Any guesses about what the branch coverage might look like for this? So what a branch means is it's a part of your code that can be reached but may not always be reached. So for example, this if statement, you might enter this if statement, you might not. Inside that if statement conditional, you see true. Right, true or false will always yield true here. However, I kind of cheated there. I set this branch up to demonstrate that there's a missing branch that we're never testing there. Now, in this case, true or false is kind of a dumb thing to test. We're never going to have that in our if statement, but if we had 2 values, and the first one was always true when we tested our code, we're never going to reach the second one. We're never going to execute it. So our branch coverage shows us that we have 4 branches and 2 of them were never executed. Anyone want to guess what the 2 branches are? Right, so one of them is the missing else. So even though we don't have an else clause, it's telling us here with that little black and yellow E that our false condition of our if statement was never reached. Or rather, our if statement was always true, meaning that console.log is always executed. We never skipped that. What's an if statement if it's always true? Pointless. So it's basically telling us that we either have a bug in our code or we have a test that's not testing something. Now what's the other branch that's missing? The false, right. So that's a little bit trickier. Well, both of them are a little bit tricky actually, but that true or false, that false part is never going to get executed. If that was actually an evaluatable expression, like a function call maybe, that would be an important thing to note in our test. So this is a little bit more obvious. If we add an else statement there, we can see that it's never executed. Our statement coverage in this case is actually less than 100%, whereas up here we had 100% statement coverage, but only 50% branch coverage. Okay, so demo time. Time for a live demo. Just kidding, I'm not going to do a live demo. I'm going to show off an example though. So QUnit is a JavaScript testing framework. This is all of their source code. Can you read that? Okay. All you really need to see is the colors. So this up here shows statements. 84.46% of our statements are executed. Our branches, 73% of them were executed. Functions, 90%. And lines, 85. You notice lines and statements are the same because usually you don't write two statements in the same line. So this green here is good. Yellow is something's missing, whether it's branch or condition or something else. Red is a totally missing statement. So as you can see, they use code coverage to indicate metrics on their entire test suite to let them know what they're missing, what they're completely missing in their tests. All right, so enough example. Oh, my slides broke. Yeah, I should have tested them. I don't know where they just went. Sorry about that. Let me restart my presentation. There we go. All right, so code coverage is a metric. Metrics are useless unless we understand their purpose. In the game of coverage, 100% coverage is the magic number. So we're always striving for 100%. If our tests execute every edge of our code, we should have 100% coverage. However, 100% coverage does not mean we have well-written, comprehensive tests. Code coverage says nothing about our test assertions, and it doesn't tell us anything about the interdependence of our various code branches and how we flow from one to the next. So you can still have bad tests with 100% coverage, but if you have less than 100% coverage, there's something you're not testing. Now, it's okay to accept that we're not testing something, but it's nice to know what we're not testing. So there's three big JavaScript code coverage tools. Istanbul's probably still the big name in this space right now. QUnit uses Istanbul. I think jQuery probably uses Istanbul. It's kind of the, well, maybe not entirely the old guard, but it uses Node, and it requires Node, in fact, because it precompiles your code. But it has a lot of tooling around it. Whether you're using Grunt, Gulp, or anything else, there's something for you to use Istanbul with. Blanket can be run directly from your web browser. It can also be used from the command line like Istanbul. It's not quite as well supported by a lot of the tooling out there, but it's definitely rising in popularity. And JS Cover requires Java, and I've never used it. I think it has like an ant build process it uses, and it was popular, I think, probably before Istanbul switched over to Node. So, just as continuous integration services notify you when your tests break, code coverage reporting services can notify you when your code coverage decreases. If you aren't using automated tests and continuous integration services, you might consider doing that. At the point where you actually consider that, you probably want to look into a code coverage reporting service because it's not too hard to add on top, and you get quite a bit for free. So coveralls is the current big fish in this space right now. As far as I know, they were the first software as a service code reporting service. Both of these two services, Coveralls and CodeCov, do not just work for JavaScript. They work for Ruby, for Python, for Java, for pretty much anything that has a code coverage tool that you can push up to them. CodeCov is the new kid on the block. So CodeCov supports branch coverage and parcel line coverage, which Coveralls does not support. Branch coverage, as you just saw, can tell you quite a bit about your code. When statement coverage seems to be 100%, you don't necessarily have 100% branch coverage. Both of these services are free for open source projects, which is great because that means if you have an open source project and you want to run your CI server for free, you can with a service like Travis or Circle, and your code coverage you can get for free with Coveralls or CodeCov. Both start at $5 a month, I think. I think Coveralls is $5 per repository, and CodeCov is $5 for all of your repositories. I was one of the, I think probably the first users early on with CodeCov, because I was searching for a way to get branch coverage with Coveralls, and somehow I stumbled upon the service. So I've gotten a lot of support from them, and I really like the way that they've been doing business recently. The wonderful folks over at CodeCov actually gave me a coupon code for you to use to get a month free if you do decide to use it for your private repositories. You can ask me for that at the end of the talk. It's actually my name, which is my Twitter handle, which you'll see at the last slide here. There you go. So that's all I've got on code coverage. I'll open it up for Q&A. I just wanted to do a basic intro there because it seems like a lot of people don't actually know about this valuable metric for your tests.
Have you gotten code coverage working for your
I almost did. So
Yeah,
I was going to get it working. The question was, have I gotten code coverage working with an Ember app yet? I think